China is building a mega propellant tank for a massive future rocket that might be used for Jupiter and Uranus exploration. On March 2nd, the China Academy of Launch Vehicle Technology, CALT, announced that it had produced the massive tank, demonstrating that it had made the breakthroughs required to produce a propellant storage tank that was both strong and thin, and light enough to use in rocket launches. In addition, China is proposing a 2-for-1 mission to the outer planets, with a pair of spacecraft launching for Jupiter and Uranus around 2030. What does this mean for the future of space exploration? Stay tuned as we explore more on these topics. China is building a mega propellant tank for a massive future rocket. China has been teasing the Long March 9 (CZ-9) rocket, a 3-stage super heavy member of the Long March family, for years. According to reports, this launch vehicle can transport up to 150,000 kilograms, 165 tons to LEO, and 54,000 kilograms, 59.5 tons to a trans-lunar injection. On March 2nd, the China Academy of Launch Vehicle Technology, CALT, reported via the Chinese social media platform Weixin that the first propellant tank for the CZ-9 had been completed. The announcement was accompanied by images of the completed tank and the numerous components that went into its construction, and they are big. The propellant tank is 10 meters, 33 feet in diameter, making it China's largest to date. This is a little wider than the primary propellant tanks used by SpaceX's Starship, 9 meter, 30 foot, and NASA's Space Launch System, 8.4 meters, 27.5 feet. It's also twice the size of the first stage of the Long March 5, FAT-5 rocket, the China National Space Agency's current workhorse, CNSA. It also has an important engineering effort that provides the groundwork for designing and developing heavy-duty launch vehicles. CALT is a subsidiary of CASC, China's largest state-owned space contractor. Additional CASC businesses specialize in rocket manufacturing, spacecraft development and construction, engine design, and more. An integral transition ring, a melon petal sample, and the top and bottom rings of the 10-meter propellant tank, from left to right, top to bottom, CALT is the photographer. It also places China third after Russia and the United States in developing an ultra-large storage tank. The super-large diameter storage tank structure is a significant aspect of the heavy-duty rocket body construction, and its diameter directly influences the rocket body diameter, carrying capacity, and scale, said Wang Hailu, editor of the CALT statement. Compared to the 5-meter diameter storage tank structure of the new generation of launch vehicles currently in service in my country, the storage tanks of heavy-duty launch vehicles must be expanded to the order of 10 meters, with significant increases in size and load. The challenge is significant. According to Hu Zhengen, a Beijing Aerospace Propulsion Institute researcher and the deputy chief designer of the CZ-9 at China's Rocket Academy, the obstacles were not as simple as boosting the tank by a factor of 2. The 10-meter tank's exponential volume requires it to be significantly stronger structurally to house several times the propellant, while simultaneously being thin and light enough to decrease the rocket's overall launch weight. As a result, the development of the CZ-9 and its components emphasizes China's advancements in innovative materials and high-end manufacturing. This includes friction stir welding, FSW, which uses heat from a rotating tool to fuse material portions without melting them. Preparing large diameter sheets and components with the precise shape and qualities required to balance strength with low weight was another problem. The 6-year development procedure, which included materials, design, component making, assembly, and welding and assessment, was carried out by more than 20 Chinese research organizations. The team previously disclosed the fabrication of several major components of the tank, including an integral transition ring, melon petals, parts of the rocket roof, and top and bottom rings. The CALT press release featured images of these components. See above. While the Long March 9 was originally intended to be disposable, China has said that it intends to adapt to a reusable design, similar to the Starship. When it is ready for its first flight, about 2030, the CZ-9 will be used to construct China's projected International Lunar Research Station, ILRS, a joint project with Roscosmos aimed at competing with NASA's Artemis program. The ILRS mission design, like NASA's, envisages the establishment of infrastructure on the lunar surface, such as a long-term base, a transportation facility, a research station, and a ground support facility. This development is part of China's greater goal of becoming a spacefaring nation capable of competing with NASA. CALT's activities involve the creation of a new crewed vehicle, slated to launch in 2027. A smaller version of the spacecraft will transport taikonauts to LEO and dock with the Tianwen space station, while a larger variation would land humans on the moon's surface. In the future, with the efforts of additional Rocket Academy project teams, it is predicted that heavy-duty launch vehicles will be growing closer and closer to us, Wang said. At that time, our country's ability to independently enter space will take a significant stride forward, as will the pace of Chinese people's space exploration. China wants to probe Uranus and Jupiter with 2 spacecraft on 1 rocket. China has revealed new Uranus probe intentions. China's Tianwen 4 mission will include the new probe. It is scheduled to depart for the faraway planet in 2030. In recent years, scientists have made Uranus exploration a primary priority. In fact, one community even suggested names for a NASA probe expedition. China is now planning a unique mission to deploy a spacecraft to Uranus. The Tianwen 4 mission will have a bigger probe bound for Jupiter and a smaller spacecraft bound for Uranus. The pair will launch on a long March 5th rocket and will use a Venus flyby and 2 Earth flybys to propel the spacecraft into the outer solar system before separating and heading for their respective destinations. Aside from the fact that it is aimed at Uranus, something else distinguishes this mission. Most probe missions have concentrated on transporting spacecraft for a single mission, but when Tianwen 4 launches in 2030, it will carry 2 probes into space, one for Jupiter and one for China's first Uranus probe. For decades, astronomers have been studying Uranus. No space agency, however, has yet to deploy a probe to the faraway planet. As the 3rd largest planet in our solar system, many people have been curious to learn more about this lovely and icy world. China's quest for a Uranus probe is unlikely to be the last. China intends to launch its Uranus probe on a long rocket on March 5th. It will be stationed alongside a larger spacecraft bound toward Jupiter. According to Space.com, China has yet to reveal the scientific objectives of these missions. Nonetheless, astronomers will benefit greatly from learning anything new about Uranus. With NASA progressively resuming efforts to land humans on the moon and even considering a manned voyage to Mars, these probes to Uranus and Jupiter may appear insignificant. Yet missions like China's Uranus probe are still as vital as they always have been, particularly if we want to comprehend what object damaged Uranus so long ago. China has already indicated that it is planning a Jupiter trip, but fresh information was provided by Wang Qiong of the China National Space Administration's CNSA's Lunar Exploration and Space Engineering Center on September 21st during the International Astronautical Congress 2022 in Paris. The main spacecraft will be dedicated to investigating the Jupiter system and will eventually enter orbit around the moon Callisto for a detailed exploration of the Galilean moon's outermost satellite. According to Wang, the smaller spacecraft will have a mass of a few hundred kilos and will travel a longer distance to Uranus. The presentation also implies that the spaceship may pass by an asteroid on their route out of the solar. The scientific goals are still being considered, Wang said following the presentation to Space.com. Previous presentations indicated that China was debating whether to focus on Callisto as a primary target, which may reveal much about the moon and the history of the Jovian system, or on Jupiter's irregular satellites, which could provide insight into the solar system's early days. CNSA had previously considered a lander as part of the Callisto-focused mission profile, but Wang claims that the most recent design contains an orbiter but no lander. The mission is part of China's developing Tianwen program, named after the poem Heavenly Inquiries attributed to the ancient Chinese poet Q Huan, born some 2,300 years ago. In 2020, China launched its first autonomous interplanetary mission, sending the Tianwen 1 orbiter and Zhurong rover to Mars. Tianwen 2 will follow in 2025, with a sample return mission to the tiny near-Earth asteroid Kamoaliwa, and a later visit to the main belt comet. Tianwen 3 will be a sophisticated dual-launch Mars sample return mission that could launch as early as 2028 and deliver the first samples ever collected from the red planet to Earth. According to Wang, the missions and plans to build an international lunar research station in the 2030s aim to encourage the deployment of human resources to develop a new pattern of international cooperation in space exploration to contribute to the peaceful use of space. There have been no reports on the projected cost of these missions. However, if China were to execute the mission in 2030, the estimated cost would rely on a variety of factors, including the mission's precise objectives, the technology used, and the extent and duration of the missions. Interplanetary missions have historically been among the most costly and complex ventures in space exploration, with expenses ranging from hundreds of millions to billions of dollars. For example, NASA's Juno mission to Jupiter, launched in 2011, was predicted to cost approximately $1.1 billion, while its future Europa Clipper mission, also destined for Jupiter, is estimated to cost approximately $4 billion. If China undertakes the Jupiter and Uranus missions, it is fair to assume a major commitment in resources and cash. We'll have to see what China's Uranus probe mission will entail. With luck, we'll also learn more about a NASA-led mission soon. That's all from this video. Do you think China's probe is better? See you at the next one.